Hey students, guess what time it is? It's science time. Get out your notes and let's start learning. Back everyone. Hope everyone's doing well. So today we're going to be getting into hydrated compounds, and part of the reason why we're going to be doing this is when we start getting into molecular formulas and formula weights, sometimes we will have to take into account the weight of the water that is contained within a molecular structure. So we're kind of taking a step back, going back to the previous chapter, dealing with the writing names and formulas for compounds, but then we're going to be going right back into more of the mathematics behind the chemistry here. So some terminology. The word hydrate simply means water. So if you think about like if you're hydrated, that simply means you have plenty of water or fluids within your system. If you're dehydrated, that simply means the opposite of that, which would mean you don't have enough water. So some compounds, as they crystallize, will trap a certain number of water molecules. And this depends upon the chemical makeup and the structure of the compound as to how many water molecules it's able to trap. So even though these are solids, they will still have water trapped within the structure. Some of these will look to be kind of like a glossy color because of the trapped water molecules. Some will look like they're completely bone dry, but they actually have a certain amount of water trapped within their structures. So the mass of the compound, when we start getting into formula weights, the mass of the compound must take into account the mass of the water molecules. So in other words, some of the weight of the molecule is also the weight of the water that's trapped within it. The way that you go about naming these compounds, what they call the nomenclature, which is, again, just the system of naming a compound. So the way they go about naming these is you use a numerical prefix for the number of water molecules contained within the structure. So if there's only one water molecule, you call it mono. 2 is di, 3 tri, 4 tetra, 5 penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. These are the same numerical prefixes that were used for the binary molecular compounds like carbon dioxide and carbon monoxide. But then what you do with these names is you attach it onto the word hydrate. So if there's only one water molecules in the structure, you call it a monohydrate. If there are 2 water molecules within it, you call it a dihydrate. There's 9 water molecules in it, you call it a nonohydrate. So it should be pretty easy to figure out the name for the compound. Now, if the compound usually has water, but then the water has been removed from it, it's been dehydrated, then the compound is referred to as anhydrous, which basically means no water. Whatever you do, do not call it dehydrated. Now, a lot of compounds also do not trap any water molecules naturally. So if it's naturally a dehydrated compound that has no water trapped within it, you do not call it anhydrous. You only say the name of the compound. So for example, sodium chloride is one of those examples, is that it does not have a hydrated form. In other words, it cannot be a crystal, a solid crystal, and also have water trapped around it or within it. So you just simply call it sodium chloride. Now, if it has water trapped naturally within it and you dehydrate it, then you refer to it as anhydrous. So not all compounds will trap water within them. The way that you write the formulas for the compounds is you write the compound first, where it's like calcium chloride or sodium carbonate or something like that. Then you'll see a dot followed right after the formula, and the dot is raised up. It's not on the bottom, it's not a period, but it's raised up. Then in large numbers, you write the number of the water molecule, except for 1. So basically this is like a coefficient number, but then you put that right before the formula of H2O. Now the only thing you don't do is you don't write 1s down. Just like normal, whenever you write out a formula, whether it be a subscript or coefficient number, you don't write 1s. So there's 1 water molecule, you just write H2O. If there's 2 water molecules, you'll put a 2 in front of here. If If there are 3 water molecules, then you put a 3. You just don't write ones down. So let's try a few examples here. So if you look at this first one, let me turn on the pen. So for example, in this one here, NO3 -1, hopefully you remember what that is. This has a -1, that's nitrate. You have 2 of those. This has a +2 charge to it. But then the key thing is you have 3 water molecules here. So the name for this compound can have 1 or 2 names, and one possible name is copper 2 nitrate. Now if it was just that, you'd just simply call it copper 2 nitrate. But the fact that this has 3 water molecules after it, the word for 3 is tri. Another word for water is hydrate. So the name for this compound would then become copper 2 nitrate trihydrate. So again, this means copper with a +2 charge, your nitrate, again you have to balance out the charges. Tri means 3. Hydrate means water. So if you look at the next one, fluorine has a -1 charge to it. There's 2 of them. That means this iron has a +2 charge to it. So this again has 2 possible names for it. You can call it iron 2 fluoride, or also it could be called ferrous fluoride. And then the word for 8 is octa. And then you have the word for water, which is hydrate. So the name for this compound is ferrous fluoride octahydrate, or it could also be called iron 2 fluoride octahydrate. And again, the word octa means 8, and then the word hydrate means water. For the next one, this is a carbonate, has a -2 charge to it. Sodium has a +1 charge to it. That's the reason why you have 2 down here to balance out the charges for it. So this is your sodium carbonate. There's only one name for this compound. And then the word for 7 is hepta. So it would be called sodium carbonate heptahydrate. And again, hepta means 7, and hydrate means water. It's not too difficult to figure it out here. So again, you just say the name of the compound first, and then how many water molecules are attached to that compound. And it just becomes all one part of its name. Now working backwards, we have plumbous bromate monohydrate. Now plumbous is a lead, and if you remember, lead has a +2 or +4 charge. This would have a +2 charge to it. Bromate is one of your polyatomic ions. It has a -1 charge to it. Now the key part to this though is mono. Mono means 1, and then hydrate meaning water. So this means this has 1 water molecule attached to it. And if you remember, for ones, you don't write ones down. So the formula for this compound is plumbous, which is lead with a +2 charge. Bromate. Bromate has a -1 charge. There's a reason why you have this in parentheses, subscript 2 to balance out the charge. And then mono, because there's 1 water molecule here, but you do not write ones down. And then hydrate, water. And then for the last one, barium, which has a +2 charge to it. And then thiocyanate is one of your polyatomic ions, has a -1 charge to it. But the key thing here is dihydrate. Di means 2. So the formula for this compound is barium with a +2 charge and thiocyanate with a -1 charge to it. So you need 2 thiocyanates in parentheses, subscript 2 to balance out the charge. Di meaning 2, hydrate meaning water. So it's pretty simple. So the next part is you're going to be doing this by yourself here. So I'm going to show you the formula for the compounds, and then or show you the name for the compounds, and then you're going to give me the other part of it. So if given the name for the compound, choose the correct formula for the compound, or if given the formula, choose the correct name for the compound. All right, so let's go. So the first one is copper 2 sulfate pentahydrate. Now, I also want to show you what does it look like when it's anhydrous. And this is the same blue solution that you were using when you were making your Christmas ornament. It was, when you dissolve in water, it makes a blue solution here. But if you heat it up gently, you can evaporate the water off of this, and it'll go from a kind of a nice blue color to almost a blue-white color, almost completely void of its color, with a slight hint of blue to it. And as you can see down here, if you add water back to this, you'll hydrate the compound. You'll make it become pentahydrate again. And a common thing that this is often used in is fungicides for plants. So what I want to know is, what is the formula for copper 2 sulfate pentahydrate? Don't worry about this part here. So the formula for copper 2 sulfate pentahydrate. Go ahead and make your selection. All right, for the next one, you're going to have COCl2 6H2O. And again, I'm showing you what does the anhydrous form of this compound look like. And a common thing that's often used for is for detecting humidity. And as you can see here, there's a big color difference between the hydrated form and the anhydrous form. So what I would like to know is, what is the name of this compound of COCl2 6H2O? Don't worry about this one over here. Now, this is something that probably many of you are aware of, is Epsom salt. Some of you may have this at home. So the formula for this is MgSO4 7H2O. Now, there's a little bit of a hint up here where it tells you magnesium sulfate, but that's this part right here. What is the full name for this compound? So also take into account the 7 water molecules. So the name they have up here is only the name for this part, but not the whole name of the compound. So I want to know, what is the name of the compound of MgSO4 7H2O? All right, the next one is it's actually used as an iron supplement. And again, if you look at the name of this compound, it gives you the first part of its name. So you have the formula FeSO4H2O. So, all right, has part of the name up here. That's this part up here. But I want to know, what is the whole name of this compound? FeSO4H2O. All right, here's another substance that some of you may be familiar with, commonly referred to as borax. The chemical name for it is sodium borate decahydrate. So what I would like to know is, what is the formula for this compound, a sodium borate decahydrate? All right, the next one is NiSO4 6H2O. This is a substance often used for nickel plating. Here's a manufacturing place where they will nickel plate various types of metals. You can see like the before and after pictures of some steel being nickel plated. But this is often used for nickel plating. But I want to know, what is the name of this compound that is NiSO4 6H2O. Now, some of you may have something like this at home. They call it a storm glass. Just FYI, no, it really does not detect the weather outside. Basically, it's sensitive to temperature changes, but it cannot tell you, it's not accurate as to what's happening outside. But it's kind of a neat little novelty device. But the chemical that's inside of here is called sodium thiosulfate pentahydrate. So sodium thiosulfate pentahydrate. what is the formula for this compound? And the next one, the formula is CrCl3 6H2O. This is what the compound looks like. And this is typically used as a certain type of additive that's used in certain types of IVs, what they call a TPN IV. So I want to know, what is the name of CrCl3 6H2O? Now the common name for this is called gypsum, and this is what gypsum naturally looks like. It's a very soft mineral, and when they grind this stuff down, this is what they make. It is gypsum board, also better known as drywall. But that is calcium sulfate dihydrate. So what is the formula for calcium sulfate dihydrate? All right, so hopefully you did well. Next time, we're going to start getting into the formula mass of a compound. A few things I would recommend gathering here is make sure you have a calculator, a periodic table, something to write with. It would be best if you would follow along as you're doing this. Another good thing to have on hand, a couple of things here, are also your ion papers, your monatomic and your polyatomic ion papers, and also the lab paper that you recently did, the counting by Wayne. So you'll be needing those materials next when we start getting into formula mass. I'll talk to you later. Bye.